Hello, my name is Patrick Simmons, and I'm an applications engineer supporting position sensing products. In this video, I will cover the joystick function found in Texas Instruments Magnetic Sense Simulator tool, also known as TIMS. Interested in making a joystick like this? Such an implementation could be designed and evaluated in TIMS. To do so, you simply need to start a design, choose joystick for movement, choose a magnet shape, and then choose a device. For our example, we will use the TMAG5273. After selecting the device, you can start entering the details for the design. In some instances, you might be starting with a guess at what might be possible. In other instances, you might already have design constraints dictated by what your mechanical team has created. In this case, we will verify if the parameters imposed by the existing mechanical design yield a usable output. Based on the existing mechanical design, we input our magnet dimensions and its relative placement. For a cylindrical magnet like ours, the outer diameter and magnet height are needed. Subsequently, the magnet position relative to the rotation axis is necessary. Once the magnet dimensions are defined, then the sensor location needs to be defined. As the tool's sensor location corresponds to the bottom center of the package, you may need to use the datasheet to account for any offset the Hall element has from the center of the package. Like other position functions in TIMS, magnet origin is at the magnet center and its position is relative to the movement origin indicated by the crossing of the red x-axis and green y-axis. The key differences for joystick is how the final position or end of travel location is defined. The tilt angle describes how much the angle will tilt away from the z-axis in that direction. The XY angle text field specifies the direction your magnet will tilt. From an aerial view looking down on the XY plane, you can see where 0 degrees is and how the magnet tilts in that direction for our first simulation, and then tilts 45 degrees away in the subsequent simulation. After defining all magnet and sensor parameters, you can then simulate and determine whether your design will work. The simulation yields flux and device output plots that help you gauge whether the signal is large enough with sufficient resolution for your needs. All data shown in these plots can then be downloaded in CSV format for further processing. Post-processing can then provide additional insights. For example, in this design, the sensor could be on the outside of the magnet travel arc or on the inside. The benefit of outside placement might be that it is mechanically simpler to implement, whereas the benefit of having the sensor inside of the magnet travel arc is a larger range of movement could be sensed. From post-processing data from one inner and one outer sensor over a larger tilt range of 45 degrees, we can see that the device closer to the origin of rotation, the intersection of green and red axis, observes the flux density diminishing more slowly. That shows how to use the joystick function in TIMS. To learn more about TIMS and position sensing related content, please see the relevant collateral linked here. To get started with designing your magnet sensing solution, please visit webbench.ti.com/TIMS.